Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Birch reduction of benzene. Benzene treated with Na in liquid NH3, Birch reduction, gives 1,4-cyclohexadiene compound A. The double bonds remain at positions 1 and 4, with the reduced carbons at positions 2, 3 and 5, 6. Actually the product is 1,4-cyclohexadiene, where C1, C2 and C4, C5 are double bonds, i.e., cyclohexa 2,5-DN1. More precisely, Birch reduction of benzene yields 1,4-cyclohexadiene. Moving on to the next step. Ozonolysis of 1,4-cyclohexadiene with O3Zn, reductive workup. 1,4-cyclohexadiene has two double bonds. Ozonolysis cleaves both double bonds. The ring opens and each double bond is cleaved to give two aldehyde groups. 1,4-cyclohexadiene, double bonds at C1, C2 and C4, C5, upon ozonolysis gives OHC, CH2, CH2, CHO, succinyldehyde, butanediol. Wait, let me reconsider. 1,4-cyclohexadiene has the structure with double bonds between C1, C2 and C4, C5. Ozonolysis of both double bonds cleaves the ring. C1 is equal to C2 gives CHO at C1 and CHO at C2. C4 is equal to C5 gives CHO at C4 and CHO at C5. The resulting open chain compound is OHC, CH2, CHO connected via CH2, CH2. The product is OHC, CH2, CH2, CHO, succinyldehyde. Actually the cleavage of a six-membered ring with two double bonds at 1, 2 and 4, 5 positions gives OHC, CH2, CHO and another fragment, but since it's cyclic, cleavage of both gives one open chain dialdehyde, OHC, CH2, CHO. No. For cyclic 1,4-cyclohexadiene, double bonds C1 is equal to C2 and C4 is equal to C5, ozonolysis cleaves both to give CHO, CH2, CH2, CHO, from C3, C4 and C6, C1 carbons connecting, giving butanediol, succinyldehyde, 4 carbons. Actually the product is OHC-CH2, 2 CHO, but wait, the ring has 6 carbons, C1 is equal to C2, C3, C4 is equal to C5, C6, C1. Cleavage of C1 is equal to C2 and C4 is equal to C5 gives OHC, C3H2, CHO, malonaldehyde portion, and OHC, C6H2, CHO, another malonaldehyde. No, since it's cyclic, both cleavages on the same ring give one open chain compound, OHC, CH2, CHO plus OHC, CH2, CHO. No. The ring opens to give a single chain, OHC, CH2, CHO, CH2, CHO. This isn't right either. The correct product, 6-membered ring with bonds cut at C1, C2 and C4, C5 gives the chain C2, CHO, C3H2, C4, CHO. And C5, CHO, C6H2, C1, CHO, but since cyclic, it's one molecule, OHC, CH2, CHO, and the other part recombines as OHC, CH2, CHO, i.e., 2 molecules of malonaldehyde. So compound B is equal to OHC, CH2, CHO, malonaldehyde, propanediol. And for the final step, Wittig reaction with 2 moles of pH 3P is equal to CH2, methylation. Each CHO group reacts with 1 mole of pH 3P is equal to CH2 to replace C is equal to O with C is equal to CH2. So OHC, CH2, CHO becomes CH2 is equal to CH, CH2, CH is equal to CH2, which is 1,4-pentadiene. This matches option B, 1,4-pentadiene. Why other options fail? 1. 3-hexadiene A would require a 6-carbon product. 1. 3-butadiene C would require a 2-carbon dialdehyde precursor. 1. 3-heptadiene D requires 7 carbons. The Wittig on malonaldehyde gives a 5-carbon 1,4-diene, not a conjugated diene. Therefore, the correct answer is B. Therefore, the correct answer is option B.